Hi there, back again with another episode. In this episode, I would like to before we start testing what we've done so far, I would like to kind of explain this algorithm from like a mathematical perspective, just for any of us watching that is like a maths lover. So before I mentioned that we kind of create three set of seeds, like three different seeds for the different three different numbers. But if you notice, you will see that we did not use this seed that we didn't use it directly. Like we did not just create these seeds and then just use them directly. No. So we still create like a unique seed that relies on one of like the seed that is associated to that particular number, and then that relies on the current timestamp. So so that means that we are trying to make sure that we create like a unique seed that is very large. Date dot now gives us a large number, which we multiply to the the other seed that was created specifically for the purpose of ensuring that three numbers are not generated in similar manner. They don't use the same seed. They use the same approach, right, to generate a unique seed, but they don't use the same base seed. So meaning that the unique seed is going to be different for them because doesn't follow the same pattern. So yeah, we kind of you take the timestamp, multiply it to with the base seed, which gives us a very large number, right? Now this large number, we make sure that we keep it within the range of uh, JavaScript's safe integer range. So we keep it like within that range. Just think of it like you have this cylinder, and then we keep wrapping. Uh, we're not wrapping like a string around that cylinder. The interesting part is no matter how many times you wrap this string around this cylinder, you still end up with a point within the cylinder circumference. So that's like what this looks like. So basically we take this and ensure that it stays within the range, this safe integer range that JavaScript supports. And then we move on to the next step where things gets interesting, and that is the sine wave transformation. So in this step, we yeah, one thing you should note about why is it we even chose sine, right? It's because sine is periodic and it repeats itself every 2 pi radians. In case you don't know what like a radian is, if you do that in degree, that means you have 2 pi degree. Oh, sorry, um, pi is 90 degrees, so that's like 2 times 90, which will give you 180 degrees. So 2 pi radians is 180 degrees. So it repeats itself every 180 degrees, and the output is always within -1 and 1. That's like the range of the output. So when we impute that large seed that we generated into this sine function, we're essentially just picking a point on the continuous wave. So remember, sine is periodic, and also there's also another thing that helps in this case. Sine doesn't really repeat itself for non-periodic input, so which means that you will get this kind of pseudo random decimal number that is between -1 and 1. So then we went on to multiply by 10,000, and multiplying by 10,000 means we just basically stretch the wave vertically. So we just try to stretch it vertically. If you draw this stuff on the wave, you have this it forms like, what's that thing called again? Well, I've forgotten the name of the curve, but yeah, there's this curve it forms, and that just keeps going. So you now try to stretch it vertically. The curve, it's kind of zigzag but curved, if you get what I mean, like zigzag or curved. And so and the reason we stretched it vertically is so that we can have like a larger range of values to work with. So for example, if we get a number like 0.7234, because most time the number used to just keep going and going. So let's say we get something like this, for example, and then we multiply it by 10,000. We'll be having, so 10,000, that's the same as saying this. So we'll be having, yeah, so we'll be having this. Now, the next thing we do to get like a random integer between 0 and 1, which is basically what math.random gives us. Math.random gives us like gives us like an integer value between 0 and 1. So to get that, we basically subtract the whole number of this from this. So that means in that case it's the same thing as saying x minus this, and when you do that, that should give you 0.6789. So this is now the random number we are using. So now this random number, because it's just like normal, like the kind of output math.random gives us, we can now take that random number and multiply it with the maximum range of value we want to get. So in this case, the maximum is going to be gotten by subtracting the minimum from the maximum. So the minimum number here is 499, the maximum is 999, so that's like 500. So we want to make sure that whatever number we are generating doesn't exceed whatever random number we are generating doesn't exceed 500. So, and once we do that, it means we can now add it to the minimum, because once you add it to the minimum, it's like you are saying, okay, I don't want you to go below 499. And adding it there also says, okay, now we have like numbers within 0 to 500, right? So adding 500 to this means you are saying, okay, I don't want you to go beyond this. But note that this is like 501 now, not 500. So it's like going to be up to but then we are flowing it, so it's always going to be around 999. So yeah, so when we do that, we'll be getting a number between 499 and 999. We could have used math.random and then maybe set different seeds, but this works. So now we have like we use 3 numbers. So basically this random trio is now an array of 3 random numbers between 499 to 999. Then we can sum it up and find the average and then round up, and that's how we get the random number we want to use for the coins. And that's it. Bye.